This video is an ad for relative homology. I hope it will convince you that adding relative homology to our toolbox is a good decision. Today we're going to talk about how to use relative homology to detect dimension. Now, a common complaint about absolute homology is that it can't detect dimension. For example, any two Euclidean spaces are homotopy equivalent, so they must have all the same homology groups. Thus, absolute homology groups can't distinguish between Rm and Rn. On the other hand, relative homology can actually detect dimension. If m is not equal to n, then the following relative homologies are not going to be equal. So this helps us distinguish between Rm and Rn. Now, by excision, if we have open set U of Rm and open set V of Rn, then these homology groups are gonna be isomorphic to these homology groups. Thus, these relative homology groups do not change when we shrink Rn to smaller and smaller neighborhoods of P. Therefore, these groups capture the local topology at P. So we give a name to them. For a topological space X, we call these relative homology groups the local homology groups of X at P. Alright, so now let's come back and explain why these local homology groups help us detect dimension. Well, that will come from the fact that these relative homology groups of Rm are gonna be non-zero only in degree m. We'll prove this using our usual tool for computing homology, the long exact sequence of homology of pairs. If we look at this pair, then we have the following long exact sequence. Now, since Rm is contractible, all of these homology groups must vanish. And if we look at reduced homology instead here, in degree 0, then this also must vanish. So in particular, these maps here must be isomorphism. In particular, this relative homology group in degree R must be isomorphic to this absolute reduced homology group in degree R-1. But observe that Rm minus a point, deformation retract to the m-1 sphere. So these homology groups are just gonna be isomorphic to the reduced homology group of the m-1 sphere. And we already computed this. We know what this is. It's only gonna be non-zero when these two degrees agree. In particular, that means when R is equal to m. Thus, we have established that this relative homology is non-zero only in degree m, and thus it allows us to detect dimension.